Welcome to Part C, and in this part we deal with initialization and the init method. Good. So in this example we're keeping with the same theme of the door class and creating objects of this type. Here I'm creating a new class called new door with this keyword called class. I still have the same 6 properties called open and locked, which are variables, and I've initialized 2 of them. So this door is closed because opened is equal to false, and this door is unlocked because its initial value is false, so it's not locked. Then I'm declaring 4 more properties, and these 3 properties are constants: width, height, and weight. And I'm declaring another property called color, and it's of type string, and it's a variable. You'll notice that these 4 properties don't have initial values. So where are they going to get their initial values from? In the previous part I mentioned to you that whenever you create a class and you create properties, you have to declare initial value for all of the properties. So here I'm declaring the properties, but I'm not giving them initial values. So where are they going to get their initial values from? Good question. This is where they get them from. Okay. We have to create a method called init. Okay. It's like a function, but it doesn't have the keyword called func in front. It's a special function or special method called init. And all classes have this function called init. It will be invoked or run automatically. You don't need to explicitly call this function. Whenever you create new objects of this type, of this class, this init function will automatically be executed and initialize the rest of the variables. So you see here I have 6 properties and only 2 of them are initialized. What the init method does is it initializes the other 4, which is the width, the height, the weight, and the color. It's a method like a function, and this method has 4 input parameters, and I'm declaring the names of the input parameters, which is width, height, weight, and color, and I'm also giving default values to these input parameters. Default value of 32, 72, 10, and red. So when a new object is created, it will get the 2 default parameters for open and locked from here, and it will get the other 4 default values from the init method, which is invoked automatically once a new object has been created. Now when we get to the body of the init method or init function, you'll see that the input parameters called width, height, weight, and color are the same names as the properties width, height, weight, and color. Okay, down here. Although they have the same names, but they're not the same thing. These ones in black are the input parameters to this method called init. But the ones in blue, width, height, weight, and color, are the properties of this class, or the properties of the object of this class. So to differentiate which is the input parameter and which is the actual property, we use the keyword self, and self here is used to indicate that we are assigning the value of the parameter to the object's property, or the class's property, called width. That's the purpose of self. Okay, so that was the additional method that we've added to our door class. In our previous door class, we had 4 functions, one called open, close, lock, and unlock. We're going to keep the same function names, but we're going to modify those functions slightly to make it a bit more intelligent. What do we mean by that? Here, we close an open door. And we modify the function to prevent an already closed door from being closed. So there's no point in closing a closed door. So what this function does is, before it closes the door, it checks if the door is open, and then it closes it. If the door is already closed, it gives the message the door is already closed. So that's the function called close. Let's look at the function called lock. Here again, we use this function called lock to lock a closed door. And we modify the function to prevent an already opened door from being locked. As you know, if a door is opened and we try to lock it, there's no point in locking an open door. So it checks to see if the door is already opened, and only if it's closed it will lock it. Otherwise it will give the message you cannot lock an open door. Let's have a look at this function. It's the unlock function, and here we use the unlock to unlock a closed door. And we'll also modify this function to prevent an already open door from being unlocked. If a door is open, there's no point in unlocking it. It's open already. Okay, that's the 4 functions. Now, once we've created the class, we now create objects of that class. I'm creating a new object called front door of the class new door, and I said to you, every object that's created, at the point it is created, it needs to be initialized. All its properties need to be initialized. All 6 properties need to be initialized. And yes, it is initialized. So the door is closed because open is false. The door is unlocked because locked is false. The width is 32. The height is 72. The weight is 10. And the color is red. Now, where did it get those 6 default properties from? It got 2 from here. Got the 2 from here because we gave it the default properties when we created the properties. And it got the other 4 from here. Okay, because the init method, when the object was created, the init method was run automatically. That's how it got the 4 properties from here. So that's why this object has got the 6 properties. So once it has the 6 properties, we can now perform some functions on this door. And its initial value says that the door is closed, but it's unlocked. Now, if it's closed and we try and close it by invoking this method, it's going to say to us, no. How can you close a closed door? The door is already closed. If we try and invoke the open method, that would work, because if the door is closed, we can open it, and now the door is opened. Now we try to lock this door, but we cannot lock it because the door is open and you wouldn't normally lock an open door. So that's why it gives this message, you cannot lock an open door. Right? Door is still open. We try to unlock the door. No point in unlocking an open door. So it gives us the message, you cannot unlock an open door. So that's how we call the methods on this object, by using the dot notation and the name of the object. We can also have a look at what the state is of the properties of this object. If I want to check if the door is locked, I just type in new front door locked, and it tells me whether the door is locked or unlocked. It says false, so the door is actually not locked. I want to check if the door is open. True, the door is currently open. And I can check the width, the height, and the weight. Yes, I can output the width, height, and weight, but I can never change the width, height, and weight, because width, height, and weight were declared as constants with the let keyword. Let's create a new door. Sorry, let's create a new object called new backdoor of class new door. Now, if you don't want to invoke the init function with those default values, okay, so you don't like those values. You don't want to use 32, 72, 10, and red as your initial values for the four remaining properties. You don't want to invoke this init function automatically. You can specify your own properties, the remaining four properties, when you create the new object. So here I'm creating a new object called new backdoor of class new door, and I don't want to use the init. It'll ignore the init method and will assign 4 new or unique values for this new backdoor. And please note that the new front door and the new backdoor are 2 separate entities. Each one of them have their own width, height, weight, color, whether they're open or closed. They have their own state. Although they are of the same type, or they belong to the same class, they're 2 separate entities. Let's try and paint my new backdoor to white. And yes, that's possible, since the color property was declared as variable, so I can change it. So I say new backdoor dot color equals to white. Hope you enjoyed this part that deals with initialization and how we can use the init method to initialize the property values once we create the objects.